expressions. Please remember to subscribe to my YouTube channel. Remember to like and also share my videos for your support. Thank you so much. Okay, so in this video again, this is what we are going to discuss. As you can see on the screen, factorizing quadratic expressions. So a quadratic expression is simply an expression with the highest power of the variable 2, as you can see. So that is a quadratic expression. That's how it can be said in simple terms. So consider that you have a quadratic expression of this form: ax squared plus bx minus c, where a and b are simply coefficients and c is a constant. Now, to be specific, a is a coefficient of x squared and b is a coefficient of x. Alright, that is a variable with power 1, that is b, and then a is a coefficient of a variable which you have in whatever quadratic expression with the highest power of 2. So here are some simple steps which you can follow to solve quadratic expressions by factorization. If you scroll up some videos, I've explained how to solve not expressions but equations, okay, quadratic equations by factorization, formula method, and also completing the square method. So here we are considering how to solve quadratic expressions by factorization method. So the first step is you need to multiply your a and your b. So in the quadratic equation which you have, you need to identify what is your a, your b, and your c. And then the first step, you have to multiply your a and your c, which will give you a product p. Then in the second step, you need to check your b, okay? And then from the product which we have found in step 1, you need to choose a pair which will give you the sum b in your quadratic equation. And then you need to substitute that b by the pair among the factors of the product p which we have found, okay? A pair, that is a pair of two numbers which when you add will give you back your sum, that is the value of b in the quadratic expression that you have, okay? Alright, so here in the quadratic expression, so that should be a mistake. There you need to have your quadratic expression and not equation. Okay, so that's what we have there. Let me just do the correction there so that you don't get confused as we solve. Okay, that's in the given expression. Good, like that. Alright, so let's proceed. So we need to substitute that and write in brackets what you have. So to see that clearly, let's solve some equations. We have in the example equation 1. So we're just going to follow the steps. Step number 1, identify your a. Okay, let me just change the color here so that you can have things visible to you. So we have two we need to identify our a, our b, and our c. So if you have equation like this, so this is my a, this is my b, negative 17, and c is 8. Okay, so the first step, I need to multiply a times c so that I get the product p, and this p will be the key to solving my quadratic expression that I have. Alright, alright, so from what we have there, which one is your a? That is from the first example, you can identify your a. Okay, just a moment, I'm changing that. Alright, okay, so identify your a, your b, and your c. So our a in this quadratic equation is 2, because 2 is the coefficient of x squared, as you can see. So we multiply that by c, which is a constant, the constant in this quadratic expression which we have is 8, right? Giving us the product of 16, right? Now we need to find among the factors of 16, okay, the pair, the factors of 16, the pair which will give us the product P and also giving us the sum B. So we know that among the factors of 16, we can have 1 and 16, right? 1 and 16 is one pair of the factors of 16. We can also have that's 2 and 8. We can also have 4 and 4, right? Now these pairs, the factors of 16, you see that let's start from the bottom and eliminate from here. We know that 4 times 4 will give us 16, right? 4 times 4 will give us 16, but 4 plus 4 won't give us back our negative 17, right? So we can't use this pair. Let's come to the second one. 2 times 8 will give us 16. That means we'll get our product back. But 2 plus 8, it won't give us negative 17. Or 2 minus 8 will not give us negative 17, which is our B, right? That's our sum. Now when we come to the first one, 16, we know that 1 times 16, we're going to get 16, right? Right. And 1 plus 16 will get 17, only that it will be positive, right? But we need negative 17. But we know that we can deviate this pair 1 and 16 by making them negative values. So negative 1 minus 16, it will give us negative 17. So we have our sum, that is our B, back by using negative 1 and negative 17. And when we multiply negative 1 times negative 16, we have our product, which is positive 16. Hence, among the pairs of the factors of 16, we can use negative 1 and negative 16 to solve the quadratic expression that we have by factorization method. So that we have chosen 1, that's negative 1, and 16, that's negative 16, right? So this means if we multiply negative 1 times negative 16, we'll get back our product, and negative 1 plus negative 16 will give us negative 17, which is our sum, which is our B. So that simply means wherever we have negative 17x, right, this can be substituted by negative x minus 16x, right? Right. So this is the second step. So wherever we have negative 17x in our equation, in our quadratic expression, we're going to substitute that by negative x minus 16x. So let's do that. So if we do that in the quadratic expression which we have, let me just bring it down, okay, so that you can follow through nicely. Alright, it's here, we brought it back. Now we can proceed. So we have 2x squared minus where we have negative 17, we're substituting this by negative x minus 16. So negative x minus 16. Then we have plus 8 at the end. Now here you need to divide, I've forgotten x here, 16. That's negative 16x. Alright, let me just write that properly. So we have negative 16, then plus 8. So you need to divide this expression in two parts. Okay, two terms, the first part and the second part, two terms. Now we need to factor out each part, okay, for the common number or variable. So when you look at the first part, this one, we can see that x is common, so it can be factored, okay, out. We can put it outside the brackets and divide x into 2x squared. That will give us 2x minus x into x, that's 1. We are done with the first part. We come to the second part, that's this one. We can factorize. 8 is common, or let me say negative 8 is common, because it can go into 16 without giving us any remainder. So negative 8 into negative 16x, that is going to give us positive 2x. Now negative 8 into positive 8, that will give us negative 1. Finally, we need to write what is outside the brackets, put them in one bracket. This gives us the first factor of the quadratic expression that we have. Again, the fact that what we have inside the brackets are of the same values, or they are exactly the same, we just get 1 and have 2x minus 1. So x minus 1 and 2x minus 1 are the two factors of the quadratic expression that we had on top here. Okay, so if we multiply these two factors, we are going to get back our quadratic expression that we have right here. Okay, you can try that, pause the video and try to multiply these two factors, and it will get you back to our original question. Okay, so let's use the same steps, 4 steps in the second one. So in this case, we have our A, our B, and our C. Now our A in this case, it's just 1 there, right? So that means I'll multiply 1 times my C is negative 15, which is going to give me negative 15, right? That's the first step. I have my product. My sum is 2 here, right? That's my B. So it's my sum. So I need to find among the factors of negative 15. So the factors of negative 15, we can have negative 1 and positive 15. We can have negative 3 and 5. We can have also negative 5 and positive 3. Okay, it's just the opposite, but usually the factors are just these. Those are the pairs. We have 1 and 15, 3 and 5. Okay, these will give us negative 15. Okay, you can either get positive 1 and negative 15, positive 3 and negative 5. They'll still be factors. Okay, so it's up to you of what you get. So let me just remain with these two. So from the two pairs we have, you can see which pair which will satisfy the conditions there. So for example, we have negative 1 times 15 to give us our product back, right, which is negative 15. But negative 1 plus 15, it won't give us our sum, which is B, which is 2 in this case, right? But we know that when we use negative 3 plus 5, we'll get back our 2. And negative 3 times 5, it will give us back our product, which is 15, right? So this satisfies the condition. So we use negative 3 and 5. Okay, so we're saying we are using negative 3 and 5. These are the two numbers we have found. Now, this simply means whenever we have positive 2x, right, this can be substituted by negative 3x plus 5x, right? Right. So that means in our quadratic expression, wherever we have positive 2x, we are going to substitute that by negative 3x plus 5x. So let's do that. So we write from there. So we have our 2 sorry, that's x squared. Whatever we have positive 2x, remember we are substituting that by negative 3x plus 5x, and then lastly we have negative 15 there, right? So again, you divide your expression in two parts. You factor out the first part. What you have common is x, and x into x squared, that is going to give you x, and then x into negative 3x, that's going to give you negative 3. Again, you factor out the second part. We know that 5 is common, that's positive 5, because 5 can also go into 15 without giving you any remainder, right? So positive 5 into positive 5x, that will give you simply x. Then positive 5 into negative 15, that will give you negative 3, right? So whatever is outside the brackets, you put them in one bracket, like that. And the fact that this and this are exactly the same, you just get one bracket or one expression that type. So these again are the two factors of the quadratic expression we have. That means if we multiply these two factors, we are likely to get back to our original quadratic expression that we have been given. Okay, let's use the same strategy. You can pause the video and try to solve this one and see if it's giving you exactly what I'm going to find here. So here I'll multiply 2 times, that's 2 times 3, I'm going to get 6, that's positive 6. I also know that if I add 2 plus 3, I'm going to get 5, which is my sum, that is the value of b, my b there, because this is my a, right? This is my a, this is my b, and this is my c, right? So this again simply means wherever I have positive 5x, I can substitute this by positive 2x, and in this case we are using z, not x. Okay, that's z. That was a mistake there. Okay, let me just correct that. Okay, that's z. So that means what I have here also is z. Okay, I'll just do that. So that's z, which is supposed to be there. Okay, and that means I have, whenever I have positive 5z, this can be substituted by that's positive 2z, that's positive 2z again plus 3z. So we will need to substitute this in our quadratic expression we have on top. Okay, so if we do that again, we can bring that down. So that means in the quadratic expression we have 2z squared. Now where we have positive 5z, this will be substituted by positive, that's positive 2z plus 3z, then we have plus 3 at the end there. Again, you can just divide this in two parts like that. You factorize the first part, you see that both 2 and z are common, so you divide 2z into 2z squared, that will give you z, okay, plus 2z into 2z, that's 1. Again, you see what is common here, it's positive 3, right? So positive 3 into positive 3z, that will give you z. Again, positive 3 here into positive 3, that will give you 1. What is outside the brackets? You put them in one bracket. You have 2z plus 3 and then you have z plus 1. So again, these are the two factors of the quadratic expression we have on top. So that simply means being taught to factorize a quadratic expression is simply being taught to find the factors of that quadratic expression that you have been given. So let's see how we can expand that knowledge here. We have 3x squared minus 2x and we are factorizing here. So that means we look for what is common on both sides of our operation. So we have negative there. We see that 3 is common because 3 can go into 27 without giving us any remainder. So that means 3 into 27, that can be 9. Now here what you need to do is to change what is inside the brackets to write it in index form. You remember the laws of indices. So 9 can be written as 3 to the power 2, right? Right. So this becomes the difference of 2 squares. So the difference of 2 squares can be written as x minus 3. So one bracket carrying a negative and the other one carrying a positive. So we have x plus 3. So this means 3, x minus 3 and x plus 3 are the factors of the quadratic expression of two terms which we have. That's 3x squared minus 27. Right. So let's also apply it here. What is common on both sides of our operation there? It's simply 1. Okay, you don't need to write 1, but I'll write just to help you be in the same line of thinking. So it's like 1 can go into x squared minus x without giving us any remainder. That's minus 16, because 1 into 16 can also go there without giving us any remainder. So we have 1 into x squared, that's x squared, minus 1 into 16, that will be 16. It's not necessary that you need to write 1, it's just that I want you to see the line of thinking which is there. Okay, because 1 multiplied by whatever is inside the brackets, it will give you the same thing. So it's not necessary to write 1, just for the sake of clarity there. Okay, again, so this we can write 16 in index form, right? So if we write 16 in index form, this can be written as 4 squared. And this becomes the difference of 2 squares. So one bracket will carry a negative, that's x minus 4, and another bracket will carry a positive, that's x plus 4. So those two are the factors of the quadratic expression we have on top. Now let us look at this one here. Again, here we can see what is common. We see that 5 and also x, they are common, they can be factored out. So that we have 5x into 5x cubic, we have x squared there, minus 5x into 125x w squared. We see that we are just going to remain with 25w squared. Right? So again, we can write 25 in index form there. So we can have x, right, squared minus 5x wx. Again, since what is inside the brackets becomes the difference of two squares, we can write two brackets, one carrying a positive, the other one carrying a negative, and those will be the factors of the quadratic expression that we have there. So the other one will carry a positive sign. So 5x, x minus 5w, x minus 5w and x plus 5w are the factors of the quadratic expression we have there on top. Okay, now I can also summarize by bringing in factorizing quadratic equation, because we're done factorizing quadratic expressions. Now let's now just give you the link to quadratic or to solving quadratic equations. We know the difference between quadratic expression and quadratic equation. So here now, let's say what we have is to deal with quadratic equation, right? So we are dealing with quadratic equation now. Okay, if that's what we have, okay, let's now deal with quadratic equation. So if an expression here was not a quadratic expression but a quadratic equation which we have been taught to solve, suppose the question was now phrased as solve the quadratic equation. Okay, okay, let me just type that so that we assume if this is the question that you have, how do you apply this knowledge to solving quadratic equation? So we have solved, that's, we're saying we have solved the quadratic equation. If we want to solve now the quadratic equation, we have the quadratic equation. Okay, we'll just get the one from the top here, any quadratic equation which we can get. Okay, suppose let's get the first one here. Okay, let's say we are given this, the first one right here, as the quadratic equation. Okay, we're going to deviate it now to become an equation, because the way it is simply a quadratic expression. So for it to be a quadratic equation, let's deviate it and put equal sign there, so equal to 0. So that now becomes a quadratic equation and not simply a quadratic expression. Now, how do we solve quadratic equations using factorization method? So it's just the link there which I want to help you with. So the procedure is just the same. Okay, the procedure is simply the same. So you're going to do the same procedure that we did here. So what I'll simply do, I'll just get the whole of this process we did, okay, from this part. Okay, that's from this part. So you're going to do everything here that we have done together. Okay, so you are going to do everything that we have done here. Okay, let me just increase space there. Okay, let me just increase space so that I can show you. You don't need to struggle again when you already have this information. Okay, so we are saying you need to go through all these stages we did together here until you reach the last one there. Okay, so if this was asked to say, was phrased as solve the quadratic equation 2x squared minus 7x plus 8 is equal to 0. So again, you look for the product P by multiplying A and C, right? By multiplying A and C there. Let me just do that by multiplying A and C. So when you look that, you are going to substitute just like we reached at this stage here. Okay, the same thing, only that when you reach at this stage, this is your quadratic equation, so it has equal to 0, right? So when you reach here again, you have equal to 0 because it is no longer a quadratic expression but a quadratic equation. So everything will just be done the same way we did until you reach the last stage there. Now here, it means these two factors, x minus 8, 2x minus 1 is equal to 0. So that means you're going to equate now x minus 8, okay, is equal to 0, or 2x minus 1 is equal to 0. Okay, this is the only difference that you are going to find. So this simply means you are going to have x is equal to positive 8, or 2x is equal to positive 1. So you divide both sides by 2, you cancel 2, or you divide, and you are going to have finally the solution to be x is equal to 1 over 2. So these are the values of x if the question was phrased as a quadratic equation which you need to solve, and you have two answers. So once you know how to factorize quadratic expressions by the factorization method, it means you can also solve an equation that is a quadratic equation using factorization method. So those are the only differences, and that is the link in between quadratic expression, that is factorizing quadratic expression, and factorizing a quadratic equation. Alright, thank you so much guys. If you like this video, please remember to subscribe to my YouTube channel. Remember also to share my videos and like my videos. Thank you so much. So if anything